About 4.5 billion years ago, the solar system, or as it's called, Sol, was formed from a dense cloud of interstellar gas and dust after a long chaotic period of violent instability. The solar system, like a mechanical clock working with exact precision, has provided the ideal conditions for life on planet Earth, and thanks to an almost godlike luck, we have a stable and comfortable equilibrium to exist within. But how long can it stay this way? For it's said that eventually all good things come to an end, especially as we live in a universe of entropy. Join us now as we glance through the looking glass and take a peek at what the future might hold, a self-fulfilling prophecy of what is to come, what is to pass, and what is yet to be. The sun, also known as Sol, the giver of life, Apollo to the Greeks, the god of many things, music, light, poetry and life, known by the Egyptians as Ra, the king of kings, the god of gods. For although the sun has many names throughout mankind's history, we should recognize that like everything else in this universe, the sun is a living, breathing entity that has a lifespan like all things. It's only a matter of time, about 7 billion years, before the great life-giver grows in size and becomes the great world eater. A red giant whose bloated outer shell will devour the entire solar system, leaving a silent peace within the galaxy where mankind once lived. Everything we know today shall be gone, and we shall return to our original carbon form, that of stardust. In the relatively closer future, smaller changes shall happen regarding the relationship between planet Earth and its moon. It is the tidal forces between planets and their satellites that are likely to have the most noticeable effects. For most of the moons in the solar system, the result is that the satellite slowly spirals away from the host planet while the planet slows its rotation. The moon gets an average 1.5 inches farther away from the Earth every year, while Earth's rotation slows by 1.7 milliseconds per century. This may not seem like much, and to our short mortal lifespans, the change doesn't merit any action, but perhaps future generations will find at some point the problem will be noticeable. As tides change and magnetic poles shift, the Earth and Moon drift apart. But who will protect us from apocalyptic asteroids? For our moon is a silent guardian that shields us from such horrors. Over millions of years, the orbit of the majority of moons in the solar system will get wider. But for a couple of moons, the opposite is happening. They're slowly heading towards their host planet. One of these is Phobos, who in Greek mythology was the personification of fear. A 22-kilometer, 14-mile moon that gracefully orbits Mars. The inward motion of Phobos is due to the fact that its orbital period is slightly shorter than the rotational period of Mars. The Martian tidal bulge tugs at Phobos and draws it in. As time passes and years go by, we'll find eventually the critical point is reached and Phobos will slam into the red planet, splitting up and causing endless chaos and devastation. And in its glory, a great ring shall surround the planet, much like Saturn, a reminder of Phobos, and perhaps a message that fear itself is not indestructible. But should we fear this? Maybe in 40 million years, so don't worry too much. Orbital resonances happen when one object has an orbital period close to an exact multiple of another. Magnetic forces are potentially disrupting what would be normal stable orbits. A current example of such would be the Kirkwood Gaps region of the asteroid belt, a region positioned between Mars and Jupiter that is currently empty because any object orbiting within them would be in resonance with the great god planet Jupiter. Jupiter is the fifth planet from the Sun and the largest in the solar system. Jupiter is one of the brightest objects visible to the naked eye in the night sky and has been known to ancient civilizations since before recorded history. It's named after the Roman god Jupiter. Mercury is the smallest and innermost planet in the solar system. Its orbit around the Sun takes 87.97 days, the shortest of all the planets in the solar system. It's named after the Roman deity Mercury, the messenger of the gods. Mercury has the strangest orbit of all, and the long axis of this, or wobbles or precesses around the Sun at a rate of 1.5 degrees every 1,000 years. Jupiter's orbit, though more considerably normal, precesses at a very similar rate, which could potentially allow their orbits to line up in a resident arrangement around 3 to 4 billion years from now. If this were to happen, Mercury's orbit could eventually become unbalanced, catapulting it on a chaotic course that could send it hurtling into the Sun, or even worse, causing it to collide with Earth. In 2009, two well-known French astronomers called Jacques Lescar and Michael Gastineau attempted to calculate the chances of such an event. Thousands of computer simulations, each of which varied the initial position of Mercury, found that Mercury's orbit evolution was a threat to the other planets about 1% of the time. The tests reveal an example of sensitivity to initial conditions better known as chaos theory, which has profound implications for any attempt to track the long-term orbits of the planets. Chaos theory is an interdisciplinary theory stating that, within the apparent randomness of chaotic complex systems, there are underlying patterns, interconnectedness, constant feedback loops, repetition, self-similarity, fractals, and self-organization. Chaos theory doesn't mean that a system can ignore the laws of physics, only that those laws operate in such a way that tiny differences in initial parameters magnify over time until they make prediction impossible. In our solar system, this means that unless you can calculate the exact positions, orbital speeds, and masses of the 8 major planets and countless smaller objects with near absolute precision, attempts to model the progression of orbits becomes impossible. It's poetic that the notion that the flap of a butterfly's wing in Brazil can set off a cascade of atmospheric events that weeks later spurs the formation of a tornado in Texas. Another complex factor that is even harder to measure is the gravitational influence of other stars and solar systems. Right now, the closest known star to Earth is Proxima Centauri. It's a small, low-mass star located 4.24 light-years away from the Sun in the southern constellation of Centaurus. Its Latin name means the nearest star of Centaurus. This object was discovered in 1915 by Robert Innes and is the nearest known star to the Sun. Astronomers have calculated the motion of other stars in the cosmic neighborhood and found that several will come much closer than that in the next few thousand years, perhaps even close enough to have their own effect on the orbits of the outer planets and the icy objects of the Kuiper Belt. Could this in turn cause more problems for us here on Earth? A cosmic game of snooker played out before us, the butterfly effect in motion. While we are uncertain about the density of the planets beyond a certain point in the future, scientists have more data and predictions when it comes to the fate of the Sun itself. As it continues to shine by the process of nuclear fusion of the hydrogen in its core, the Sun will brighten slowly but steadily over the next 4 to 5 billion years. This will have severe consequences for the habitability of our own planet Earth and others, but these consequences are nothing compared to what comes afterwards. In about 7 billion years from now, the Sun will exhaust the hydrogen fuel in its core and begin to go through a series of dramatic changes, much like the caterpillar becoming a butterfly. The exhausted helium-rich core will begin to contract, releasing gravitational energy, while hydrogen fusion moves out into the surrounding shell. Eventually, this makes it hot enough for the helium to undergo nuclear reactions, producing carbon and oxygen. But in the short term, it also heats the hydrogen-burning shell, causing fusion to run faster than it did in the core, and therefore increasing the Sun's energy output at least 1,000-fold. As the Sun becomes larger, the surface gravity also decreases, and mass is less strongly bound to the surface. Mass loss caused by the solar wind, the stream of particles blowing out from the Sun's surface. By the time that helium ignition takes place in the core, the Sun will be more than 200 times larger than it is now. But it will have also lost about 20% of the Goldilocks zone, which refers to the habitable zone around a star where the temperature is just right, not too hot and not too cold. Unfortunately, the habitable zone moves rather slowly for most of the Sun's red giant evolution. This means that Mars, for example, will only enter the habitable zone 6 billion years after the Earth leaves it, and will stay for 100 million years. Is this the end of our solar system? Remarkably, recent work by astronomers at the University of Hawaii suggests it might not be. They investigated the possibility that new planets might form in the aftermath of the Sun's burnout and asked whether they might be able to support life. The idea is that the remains of these destroyed first-generation planets might be able to re-emerge into a second generation of planets once the star runs out of hydrogen and transforms into a white dwarf. The small size of the Sun's white dwarf remnant would make it far fainter than the present-day Sun, and would mean that any habitable planets would need to orbit much closer in order to maintain life. White dwarfs are like hot embers left after the fire goes out. They start out bright and hot and slowly cool for the rest of eternity. Just after the formation of the white dwarf, the habitable zone is relatively far away and evolving very rapidly. But as the white dwarf ages, the distance to the habitable zone moves inward and the evolution slows down. A planet orbiting at a distance of 0.01 AU will be within the habitable zone for 8 billion years from about 2 billion years after the formation of the white dwarf. Even if the solar system as we now know it is doomed to die when the Sun expands into a red giant, it's comforting to imagine that a new system of strange planets orbiting our burnt-out star will be there in the far future. Of course, if mankind is still alive, we no doubt will have transcended into a godlike species with technology that can slow down, reverse, and perhaps even stop these cosmic events. Will we even need these third-dimensional realms? At least for now, we can sleep at night, for the dangers are a long way off and problems for our ancestors. But if you can take away anything from this video, be it that when you look up and see that great ball of fire in the sky, when you feel its warmth embrace you, know that like everything around you, it too has its own lifespan and should not be taken for granted. Giver of life, giver of warmth, the world eater. And when the time comes, perhaps we shall be blessed with a supernova, whereupon our every atom shall be spread infinitely across the galaxy as we seed new solar systems and planets with our stardust and return to the great cosmic playground.